and welcome to Elvatech's channel. Today, we are looking to how XRF analysis using our handheld analyzer ProSpector 3 plays a key role in analyzing ceramics. And yes, this is not a dining table. This is actually our objects for analysis. So, from construction materials to fine art and electronics, ceramics composition can significantly affect quality and safety. Ceramics are widely used in various industries, and understanding their exact composition is really crucial. In this video, we will explore the benefits of using XRF technology to analyze ceramic material quickly and accurately. Ceramics have a complex chemical composition, which determine their durability, safety, and suitability for specific applications. Knowing the exact makeup of ceramics helps manufacturers ensure that their products meet quality standards. For instance, testing construction styles for strengths or analyzing antique ceramics to understand their history. Accurate analysis helps verify the integrity and safety of each piece. With XRF analysis, we can get detailed elemental breakdown of ceramic samples. ProSpector 3 uses X-rays to penetrate the material, exciting its atoms, which then emit fluorescence radiation. This radiation revealed the exact composition of the sample. The best part, XRF is a non-destructive method, meaning we get detailed data without damaging any sample. This is especially important when working with rare or valuable pieces like archaeological artifacts. ProSpector 3 has several advantages for ceramic analysis. It's a portable device, allowing you to take it directly to the sample, whatever you are in a lab, or at the production site, or at the field. No need to move or prepare the item specifically. ProSpector 3 is also compatible with ceramics of various shapes and sizes. Unlike traditional lab equipment, this handheld analyzer is ready for instant use on object without special adjustments. Compared to other methods, XRF technology with ProSpector 3 offers higher accuracy and is adaptable to most ceramics types, making it an incredibly versatile tool. Now, let's walk through the analysis process. First, we set up the sample here. We have 3 samples of different shapes. With ProSpector 3, there is a minimal preparation required, which saves time and ensures we can analyze ceramics on the go. So, once the sample is in the place, simply select the ceramics mode on the analyzer's menu, and then you can just adjust the time and start your analysis, verifying the composition of the material. So we are moving to our analysis itself. And firstly, we should turn on our device and scroll in the menu to the ceramics calibration, and then we can set up. But for our analysis today, we have fine pieces of Ukrainian ceramics that was made mostly for dining. Some of them were made as a souvenir. So we're gonna analyze all of them. And as you can see, they have different shapes, different sizes. And in most cases, we could think that it's gonna be hard to analyze object like this, for example, because it has like 2 different layers of ceramics. It could get different composition, but we will show you how to do it anyways. You can analyze it from a lot of points, just need to find it on the object. So, as our devices turn on, just need to make a final setups. It's to select the calibration. Yes, we have one for ceramics. And also we need to select the duration of our analysis. Basically, we always put it for 5 seconds as the fast screen. But anyways, even in 5 seconds, we will have the full composition of the element that is there. And if you need more detailed analysis, you can set up the duration of analysis for longer, or get a spectrum itself from the device and analyze this on your computer with our special software. But let's move on to the analysis. So the first piece is ready. We also just cleaned it up a little bit, and you can do it also using the alcohol and the wipes. Just clean it out, the surface, let it dry, and then commit to analysis. So as we done already everything else, here we have the piece with the good surface, and it's really easy to find the spot for analysis. So let's start. And all analysis for ceramics would go in two phases, so two pieces, right? And if you select the time for analysis for 5 seconds, basically it will take 6 seconds, because you will need to have 1 second for first pass, and then it will go 5 seconds for second pass. So we have our analysis done, and let's look what the composition of our object for analysis, or we can say it's sample for today. So first of all data goes in oxides, and here we have oxide of silicium, which is actually 51% in this sample. And for ceramics, it's absolutely understandable picture that the silicium will be the leading element in all the pieces. So the next one, we have oxides of zinc, and it's just a little bit like close to 22%. Then we have oxide of aluminum, which actually composed at 15%. We have oxide of calcium, oxide of iron, oxide of potassium, and they have like small concentration, just a little bit over 1, and everything else is just below 1. So it's next we have magnesium in the amount of 0.7, and also a lot of different oxides here. So yeah, this is the composition of a lot of elements presented here, but for sure the oxides of silicium is the leading one. All right, and now let's move to the second sample. This one we have two, actually this one is circular, but we can select any side for a measurement. Look into this one, we prepared this side, so let's make analysis here. Yes, it can lay down like this, and the most important thing is not to touch the object of analysis. So we're gonna do it like this. I mean, not to touch the object of analysis while you're doing analysis. And before and after, you can do it anyways. It's not harmful, or it's absolutely secure with this. Alright, and we have the second result of our analysis, and here the leading oxides is for sure silicium. It consists of 78%, so it's definitely the base of this material. And the second one, which is actually consists almost 10%, is oxide of aluminum, 9.5, and then we have calcium, oxide of ferrum, oxide of potassium, and everything else, starting with barium, everything else is going below 0. And here we have just a small data of lots of other oxides, but in really small concentration, which usually happens in ceramic analysis. Right, so we're done with our second piece, and now we have probably the most interesting one with its shape and the way it looks and the way how to make an analysis on this one. So let's try to do it firstly. Here we have two pieces. First of all, we have two pieces here for analysis. I mean, we have two covering materials here, but we gonna measure both of them. Alright, so let's move on to our third analysis. Firstly, we're gonna measure this spot over here. like good beam for analysis for us. Anyways, even the shape is circling, but we still can find our spot. Yep. Alright, so here on this surface, which is actually the darker, we will call them dark and brighter. So on a darker surface, we have the result that actually seems to the second one, to this one. We have the 76% of oxide of silicium. Then we have 12% oxide of aluminum. Then we have calcium, oxide of, we have calcium, oxide of iron, we have oxide of potassium, and all of this data goes as the 3 point something. And all other elements, again, starting from barium, is just below 1, so it's 0.1. And again, we have a big concentration of different oxides that presented in this material. So basically, it's almost the same, like close to the same surface, right? But they are made as the different pieces. And now we're gonna analyze another piece, another surface that we have here is the brighter one. So let's position our device. Also, our camera helps us to check if we covering all the surface for analysis. And as soon as we're done with this, yep, we can start the analysis. Alright, we're done here, and definitely here we have a different situation because we need to concentrate our attention on two elements and the difference between them. So on the brighter side, we have the silicium in concentration of 78 and more. And on a brighter side, we have silicium with concentration of oxide of silicium with concentration of 63.4, so 63%. And then aluminum, again, in the darker side, it was close to 9 and then 12. And now we have the concentration of aluminum almost 30%. So it's definitely have its influence on the color and on the surface of material, because surely they look different, they feel different, and they are different, but they made in just one piece, in just one good. So definitely happens with ceramics. And looking to other elements, we have the same 3.8 of oxide potassium, 2.6 from calcium, and all other elements starting from oxide of iron goes lower than 1. So it's just 0.71. So, as you just seen, within seconds you can get full elemental breakdown. This fast, reliable data gives you insights on everything from rare elements to the overall composition. ProSpector 3 is also invaluable for analysis to delicate and valuable pieces such as antique ceramics and archaeological artifacts. By determining their elemental composition, we can gather insights about their origins, history, and authenticity. In conclusion, ProSpector 3 is an essential tool for anyone working with ceramics. It provides fast, accurate, and non-destructive analysis, making it ideal tool for quality control, researches, and preservations. Thank you for watching. And if you'd like to learn more about ProSpector 3 or have any questions about ceramic analysis, feel free to contact us. And don't forget to subscribe for more insights on XRF technology. Be sure to like this video if you found it helpful, and we'll see you next time on the Elvatech channel. Stay tuned and see you soon.